All right, this problem is also in your notes, so please, please, please take advantage of what you see there to learn for the material that's in this section. All right, so what happens if you have g of x equals 1 over x squared? Okay, notice the red, both of these are 1 over x squared. And then you have the black one, which represents f of x equals x squared. And this says your a starts at 1 and your b starts at 3. So let me graph that on my calculator for you. So y equals, put that out, we have x squared on one hand. There's that. And then we have also 1 divided by x squared. Okay, so now you can see what I mean by the 1 over x squared having two parts. Okay, so if it makes you uncomfortable, then change your window. You want to see more of what's going on up here. Didn't mean to make that blotch on my calculator, but let's see, my window, I make my y's go from -1 to, I don't know, 5. And then my x's, -5 to 5. Let's see what happens when I do that. Okay, you may have to toy around with these to figure out what the best window is for you. Okay, so I'm going to try to figure out what happens at x equals 1 and x equals 3. So second calc, second calc. Oh, I'm putting in alpha. Second calc, number 1, evaluate at x equals 1. And notice it has it right at this intersection, which is fine. Let me draw that in. So here's x equals 1. And then they're also saying what happens at x equals 3. So second calc, number 1, plug in 3. And it's not showing it to me, but we can either change the window, or else you can see that if this is 1, that's 2, that's 3. It should be somewhere over here. So this is x equals 3. Right, I'm going to change my window so that you can see it. Okay, so let's see, second calc, number 1, plug in 3, and notice now you can see right there. Okay, so that gives me the other point of interest, right? So to be clear, if they're asking you to find the area trapped between these two functions, technically you could pinch those two together. You could pinch these two together. Over here you could pinch that together, and we could pinch this together, right? So this is what we're interested in, because we also have to be trapped between 1 and 3, right? So you have to figure out what's the overlap between your x pinches and your function pinches, and that clearly is this region right here. All right, so let's do top minus bottom. We're going to drop our pen down, and we're going to ask ourselves which is the highest one in this region, right? Just this region that we're talking about. Okay, notice the highest one up is x squared, and the lowest one is 1 over x squared. So if we do top minus bottom, or upper minus lower, depending on your preference, the integral of x squared minus 1 over x squared, the whole thing dx, and this runs from 1 to 3. Okay, so if we were to do that, then we go into our calculator, and notice since I'm doing them both at the same time, I'm creating a hybrid, right? Smashing them together, right? So whatever I get, it may or may not look like this. We don't know what it will look like. So on my y equals, I'm going to put exactly what I have here, the hybrid. X squared minus 1 divided by x squared. Graph that. Okay, definitely doesn't look like what we have. Second calc, number 7. Lower limit is 1, upper limit is 3. There we go, 8 units of area. Okay, so I wanted to do one more problem because I think you really need to be aware of this type of a problem. So what I did is I used this problem and I beefed it up. Okay, so let's consider this one. Okay, let me show you where the difference is. Here, this one says start at x equals 1. Wait, let me put it in a different color. So start at x equals 1. And the big difference between that one and what I'm about to do, this one says start at x equals a half. Okay, it's the only difference between the two problems. So let me go back in and I'll start over. And I still have 1 over x squared as one of my functions. 1 divided by x squared. And for the other function, I have y equals x squared as the other function. Graph them both. Okay, so now I need to figure out what happens at x equals a half. Second calc. Number 1 and 0.5. Well, that's interesting. 0.5 is before the point of intersection. So this is what I have. 0.5 is right here. Right? And we already know the point of intersection itself is x equals 1. And over here is x equals 3. And it says right in the problem that I want x equals 3. Now this is where things get interesting, because if you look closely, you actually have the region that we had from before, which we know that this is 8 units of area. But we've got another region. Look, I said you have to pinch between the function and the x-axis. Bam. Has to start at x equals a, has to end at 3. So now you have a second region that you have to worry about. Let me be clear, you're always pinching between your function and the x-axis. So you not your functions together, not the x-axis anymore. Pinch your function together. Here, pinch your function together. Over here even, pinch your function together. And here, pinch your function together. But they've given you other parameters. They say you have to start between x equals 0.5 and you have to end at x equals 3. So you've got two pieces. You have a left piece, which is new, and a right piece that you already know. So let me write them down. And you have to do them separately because they are separate regions. All right, on the left, if I drop my pen down, this is what I'm calling my left region right here. This is left. And this one I'm calling my right. On this left region, you'll notice that what's on top is not x squared. Instead, it's 1 over x squared. So on the left, we have the integral of 1 over x squared minus, notice what's on the bottom on the left, x squared, the whole thing dx. And the left piece, this is what's interesting, runs from 0.5 to 1. 0.5 to 1. Okay, now we also have a right piece. Now I'm not going to put them on the same level because I want you to see that they are separate. This right piece is the one we already calculated. That one starts at 1 and ends at 3. And in that case, notice what's on top. It's the x squared that's on top. And the 1 over x squared is underneath. Right? We're going to find those and then we'll add them. Right? They are separate calculations. Notice we cannot smash them together because their interval is not the same. This one goes from 0.5 to 1. This one goes from 1 to 3. So we already know that this one's 8. And we're going to add to that whatever this one is. All right. So go back into your calculator. Let's clear everything out. I'm going to smash them together. Do it all at once. So let's see. 1 divided by x squared. Be nice if there were parentheses around that. Oops. Second insert, parenthesis, minus x squared. Ugh. Graph that. Second calc, number 7. Lower limit 0.5 now, and upper limit is 1. And that's 0.708. So this is 0.708. So when I ask you about the area that's trapped between these two curves, you're going to tell me 8.708, which is the sum of your left piece and your right piece.